Yeah, we'll start now. It's 6:05. So, okay. I thought only 10 people joined. Maybe other people may join for the other classes, I guess. You people have joined the other classes? Okay. Okay. Not two more class, only one class more. Okay, okay. So, the same questions which I thought you that was there, or what was the content? Questions are different. Okay, fine. Huh. Okay. So, let's start. So, I'm sharing my screen. Okay, I hope my screen is visible, right? So first of all, I will start with the previous class discussion pollutant and contaminant difference. So okay, so this window I just want to show you what is the composition of the drinking water, the permitted level. Okay, for example, you can see in my screen. See here. Okay, this is different. Okay, okay. Yes. So the drinking water has different minerals. So if there is no such minerals are present or elements are present, what is called that water is called a name. You know the name? If there is no such chemicals, only H2O is present. What is the name of that pure water? No, there's you have heard of distilled water, DI water. DI water. So the conductivity of DI water is what? Anyone can tell? It's zero. So we measure the purity. One way to measure the purity means pure H2O is present or not. That is the DI. We measure the conductivity, and then when we see that conductivity is very high, that means there are a lot of ions are present. So here we will see. Here I have shown the different elements present. When we say, if see here, calcium, magnesium, phosphorus, potassium, copper, iron, zinc, sodium, manganese, and everything is there. So, if this is like the normal quantity of the water it can permit while drinking, which is safe for drinking. But when we see that it is, you know, this concentrate can increase from the different sources of other external factors, right? So that is called, like, when the permitted means quantity of this minerals increasing means, that is called, it is a contaminant water. Okay, so even in the previous class there was a discussion about the arsenic. So arsenic in normal groundwater also in very small quantities are present. So may in some cases, but if it's very small, then it is fine to take, because it is in the very nano to low level. 0 to 0.0000001 percentage, or it is very small, then it is okay to take. But if the concentration is high, means by different industry or from other source, it may come and accumulate. If it's accumulate in the drinking water uh, higher amount, then it is called, it become a contaminant. Okay, so another example I will give you, mercury. What do you think, mercury is contaminant or pollutant? Anybody can answer? Mercury is a contaminant or a pollutant? That means not everything. I'm saying, like, see here. Okay, somebody is joined. I think you have asked the question, right? Previous. Yes. So the normal drinking water concentration. Okay, I will take chemical composition of. There are a lot of people joining now. Okay, after adsorption. Okay, just give me a second. Like, yes, this is like WHO guidelines for drinking water. That is the maximum limit. Can you see the screen? Yes, here. See here, this is the normal element chemicals present in the drinking water: calcium, fluoride, iron, lead, magnesium, manganese, nitrate, sodium, sulfate, and zinc. So here, if this is the allowable limit. So if this limit, if the calcium is around above 200, or it may 300, 400, then it become a contaminant. If it's present this within this limit, it is not a contaminant. And here they haven't given the arsenic also. Even in some groundwater sources, arsenic also can present. Okay, so that, but it will be in very very minor quantity, very minor quantity. So if that is exceeding the limit, if it's very small, then there is we can't call it as a contaminant. But what I'm saying you Okay, for the arsenic, I'm saying. But there are some other thing. If it's presented in very small quantities, also it can call the pollutant. For example, mercury. Okay, mercury. If it's presented in very small, also it is a pollutant. Other than that, you can say some other also pesticides. Pesticides, mercury, and then sulfur dioxide. So these all things are a pollutant. Even if it's presented in a very small quantity, still it is a pollutant, and it's affect the human health. Arsenic, otherwise, if it's very small, that I'm saying you, it's a very small quantity, then it is not a pollutant, it is a contaminant. And you asked in the previous class also, we are making a synthetic wastewater. Synthetic wastewater, you are saying, right? In the previous class, this yes. Okay, so yes, see, this is like normal, what WHO permitted limit of the uh, chemicals. So if you prepare some wastewater, synthetic wastewater, then what you do, you will increase the concentration of these all parameters. If these all parameters are exceeding the limit of allowable limit, then it is a contaminant. That is called a contaminant. But even arsenic also, what I said you, if you add very little, which is the allowable limit of human consumption, it is fine. But even it is exceeding the limit, then it become contaminant. Otherwise, if you add directly even the small quantity of mercury to prepare the synthetic solution, it is a pollutant. Or you are adding mercury, or you are adding some pesticides or sulfur dioxide directly to prepare a synthetic water, that is a pollutant. Okay, got it. Hope you guys got cleared on this. Okay, now we'll go for next assignment 2. So I will add more questions on this pollutant and contaminant. I will ask so that you will get more idea on that. So hope you guys have already seen the lectures. Okay, so we'll go for the first question. First question is, what are the parameters based on which we can estimate the quantity of municipal wastewater generation? Okay, this is the question. So options are: option A, number of inhabitants; option B, per capita water demand; option C, ratio or percentage of water generation. So, what do you think? Which one is the right answer here? What are all of the above? That is right. So, why this is coming? So, we'll go and see the few points here. Okay. First of all, we know that wastewater, if we take a wastewater, then wastewater can be from municipal, industrial, and agriculture mainly. So, what do you think? Which one will be the most polluted wastewater from this three? Anyone can tell which is the most polluted wastewater? Yes, that is right. Industrial one is the most polluted type of wastewater. So, when we see here, what you do, we have to treat the wastewater, or we have to anyway collect the wastewater from this all places, right? So then we have discussed about the. Okay. So then what we have discussed about these non-point and point emissions and sources, and how can we collect this wastewater from each places and treat it. So for the collecting, we have told that they will be collect sewage pipes are there. Sewage pipes. So this sewage pipes can be the from the municipal sector, and during the that places there will be agriculture field, so there will be wastewater. So the wastewater can from the agriculture field, and also small scale industries are there. So this pipe, like, it will collect all the wastewater from the different fields, and then what we get, we have to treat it. So then this wastewater pipe, this is very important to design the pipe. We have to consider a lot of parameters to understand how big we have to build, how big we have to look for the drainage system. That is very important here. Why it is important, anyone can tell why we have to estimate the size and the volume of production of wastewater? So why we have to okay, why we have to be careful on this thing? Hmm. Yes, yes, that is right. Correct. Yes, yes, correct. That is the one point. So, Very good. So what drainage, we if we have a small drainage system, and what is do, so a lot of what water can generate, and it can break, and it this water can penetrate to the groundwater, and it will contaminate the or pollute the groundwater, and also some water sources, pure water sources, it all will be get affected if it's some breakage can happen. So in every municipality, so that is the main problem nowadays in our places also, about where we are living. So if we are living in a city area, or then there will be an efficient drainage system is required. So otherwise also there is a possibility that in the previous class also we have discussed that people throw anything into the drainage system, that is plastics and all. So if the plastics come, what happens, so it will block the flow, and it won't flow properly. So if the also you have to say about the flood, flood in the cities, it is the major hot topic. So anybody from south states where the flood previously recently some flood has happened, I think in Chennai, and in Kerala also, in some places the flood is a hot topic now. So any people have heard of this flood? Okay, how the flood and this drainage system are related? Anyone have answer? Yes, that is right. And if it's a combined system, then there is a possibility that there will be some blockages also in the system. And then what happens if this flood or the storm water also cannot pass through the drainage system, then it will accumulate on the surface, in the surface. So then what happens if there flooding can happen, the water level in the surface can increase, and flood can happen. So if we have an efficient drainage system, for the storm water separately, and also for the industry separately, then, and also with accounting the amount of water, we have to efficiently build the system. If the system is not efficiently built, then even the chances of flood is also very high. So what is, like, on what basis we can design a good drainage system? One, we have to understand, so when we take a city, we should know how much amount of water, for if we, for example, in municipal sector, so there are homes, how many homes are there, and how many people living there, and what is the approximate quantity of wastewater production, wastewater production. So wastewater, amount of wastewater production quantification is very important in the drainage design, the system design. So if the wastewater production is high, we have to build the system accordingly. Okay, so how the wastewater production depends on the people, a number of people. If the number of people is higher, then the amount of water used for the different purposes will be high, and then we will estimate the amount of wastewater is also high. So this number of people, so now it is 2024. So if we want to design a system, we should look forward, you know uh, 20-30 years more, then how we can expect how much people will be, population increase, and amount of water, how what we can expect in the coming years, and amount of industrial development happens in the adjacent years, and how much wastewater produced in those, that prediction of wastewater production is very important. So before that, going into it, There's one more term you have to understand. What is dry weather flow? You know any idea what is dry weather flow? So you have seen the lecture, right? So what is the dry weather flow? Okay. Yes, yes, right. So only in the dry season. So that means we are not counting the storm water which is from the rain flow. So this is the actual wastewater produced from the, from municipal industry, and also even agriculture. Also, we can't tell that much water without without rain. So that is the actual uh, wastewater produced. So that means, this is we have to estimate. This is we can predict from the number of people in the area, industries in the area, agriculture field in the area. So but which is not in our hand is the in the rainy season. So rainy season, like we can expect anything, because if the rain is very high, the amount of water which can come into the drainage system is also high. So you know about rainy season. So sometimes cloud burst is a phenomenon where a lot of, because of the quantity of rainy clouds in the sky, in a specific region, a continuous rain can come. So that means that area, the amount of water which increase very quickly in a smaller period of time. Okay, so this is rainy season which is uncertain, but what in our hand is dry weather flow, which we know the actual amount of water in the water from these industries. Okay, so from next, okay, then when we go back to the first question, now we see what are the parameter based on which we can estimate the quantity of municipal wastewater generation. Number of inhabitants means the answer was all of the above. Number of inhabitants, as I told, the amount of people who are living in the specific locality. Then what, for that particular amount of people who are living, what is the amount of water they need for their daily activities. Then we should know the ratio of water uses to the waste stream generation, or like how much the daily consumption. We should know how much water they use for the different needs, and how much water the waste stream can produce from the consumption of the pure water. So these all things are very important for the municipal waste, to quantify the municipal wastewater generation. So next question, the flow in the sewer line occurred during dry season is referred as dry weather flow. Which one of the following parameters does dry weather flow depends on? So our options three are four are given. Quantity of wastewater generated. So water loss through cracks and faulty joints in the water supply network, runoff into the sewers, and D option is all of the above. So the what is the flow in the sewage line which is given here? Which of the following parameter does dry flow depends on? So what will be the answer? Dry flow means which only quantity of wastewater generated. That is right. So why we are not considering runoff? Yes, yes, yes. Yes, right. So what about water loss through the cracks and faulty joints? Okay. Okay, right. So when dry season means actual amount of wastewater that is generated, we are considering. So that's the point. So next question, which of the following statement is not true regarding separate and combined system? So first of all, what is separate and combined system? So we should know the difference between Separate and combined system. So what is separate and combined system? Anyone can tell what is the separate and combined system? Okay. So the okay, that is right. So here separate means the sewage has different pipelines, and the storm water has different. So combined means in both it is, combine the sewage flow and the storm flow. Which one is economically feasible? Means economically more, lower cost. Combined. So that's why many of our drainage systems in, nearby areas are combined. So which is more efficient is the separate one. So which even in this sewage, if some solid, solid waste can also come and clog it, which will block the flow. If the sewage, like from the home itself, if the sewage water has some solid things which do not dilute in the water, so then it will affect the sewage system. In combined system, due to the storm water flow from the upper surface itself, a lot of solid contaminants can flow through the drainage pipe, and there is a higher possibility that it will clog the clog the way. And also one more thing, that when a lot amount of water is flowing, that means a lot of pressure can felt in the outer side of the pipe, and this pressure also can initiate the cracking. So if the crack is generated, this crack can, this the presence of one crack will assist the cracking of different areas. Also this wastewater is flowing out of the drainage lines, so this is very harmful for the environment. So here, coming back to our question, which of the following statement is not true? So not true regarding separate and combined system. One, separate system is more economical. B, combined system usually remains unreptilized in dry season, and combined system requires only one set of sewer pipes. None of the above. So which one is not true regarding separate and combined system? Which one? So according to you, it says C, combined system requires only one system, which is not true. See, which is not true. You have to identify the ah means which is not true. Okay, the question is the statement which is not true. So for C, it is, see, combined system requires only one set of sewer pipe. It is right, right? The question was which statement was not true. Yes, yes. So the not true means A, right? So separate system is more economical. So that is not true. Separate system means it is, we need more cost. Okay, more, so we need more pipes, we need more, so the cost of pipes for the installation. So these all things need more, cost. So A is the wrong answer, wrong option. So for which among the following is an input component of quantity estimation of sewage? So, which among the following is an input component for quantity estimation of sewage? Water discharge from household, used water discharge from various public places, private water supplies to fulfill water demand. So, which of the How we are estimating amount of sewage? What is the answer? Option D, all of the above. That's right. So when we estimate the sewage, every these all things we have to consider. So then only we can estimate amount of sewage water which is produced. Okay. Now, okay. So next question. Usually, the observed dry weather flow quantities are slightly less than per capita of water consumption. So during this is the dry weather flow. Okay. Dry weather flow, that means we are not considering the run of water. Only the waste stream which is produced from different sectors that we have discussed. So which is the estimation, when we calculate the estimation, it is always less than the per capita water consumption. So what is the reason for that? For option A, some water is lost in evaporation, some water seepage into the ground, leakage in the pipes. So what will be the reason for the lesser than the estimation? What is the answer here? Option D, all of the above. That is right. So how the evaporation happens, that we know, right? From the So when water we are collecting in the, when we estimate, we will collect in some, so a small a big tub or big bucket or something. That amount of water we take. So after some time, when we see the amount of water, the weight reduction is, we can observe if we measure the a minute reduction in we can observe even after few minutes. That means, like, what are the different evaporation that is happening here? So you know that daytime also, when the sun is there, the evaporation is high. That is due to the solar energy. So even at night also, if we collect some water, and then when we check in the morning, there is a minute reduction in the water. That is due to cold evaporation. So you know about cold evaporation. What is cold evaporation? Okay, so that is simple thing. Like, I will tell you. That means, like, we have some water. So if it's an open source, even it's a pond also, if it's a big water source, then what happens in the, when solar energy, that means the daytime, it will absorb the water, then water will evaporate, right? And then at night means we don't have the solar energy, but still. And also there is one more factor, which is wind. So wind also will assist the evaporation. So at night there will be a small, okay, wind may or may not present, but there is no solar. But even at this point also, there is a minor, evaporation happens. That is weight reduction of this water is happening. So that is called cold evaporation, without the presence of solar. So this all evaporation will decrease the amount of water that we estimate. Then next point, some water. Yes, yes, yeah, sure. Yes, sir. It's good. Yes, yes, sure. So the cold evaporation means water molecules are present in the interface, and even this interface, this molecules are loosely, this the attraction force towards the other molecules is less. So for the top level of top the molecules which is present in the top section. Then if there is small wind or something, this is always be in motion. So this molecules can easily escape from the bond between the other molecule which is present in the down section. See, if the water molecule is here, it has a attraction or force from the all direction. So but here, these molecules which are present in the top section, which is always be in the motion, and it is the attractive force between other molecule is less. And if there is more, some small wind also there is the the kinetic motion of this molecule is high, become high, and these molecule can easily escape the surface. So that is called cold evaporation. That means the cold evaporation, that means it will be very less. Cold evaporation will be for them, it is when we consider the big, and you all know about the bulk water, right? So here this is like bulk water. So heating, what happened, the heat will come, and then this heat energy is transferred to all the other regions. Then only the water will escape here from the, it will get some energy. This energy will help them to break the attraction between other molecules, and it will go as a vapor. And in this case, the solar energy, that means heat energy, also here the kinetic motion of the water molecules can also provided from wind. So in the cold evaporation, thermal energy is not, they are not getting the thermal energy, but they are getting the kinetic energy from this wind or small motion of this above. Air molecules are always be in motion. So this air molecules above the water help to escape from the water body to transfer into the vapor state. That is the cold evaporation. So even yes, yes, it's okay. So even if you keep a open water at night, and then you see the water at morning and measure it. So if you measure, there is a, surely there will be a reduction. So that you can g- get. So then next point. Yes. Okay. Sorry, I didn't get. Yes, yes, clothes, right? Clothes. Yes, yes, right. So that is the perfect example. Yes, yes. That is good, good. So that means like if you just hang your, so that is another thing I will tell you. That is not of this type. That is also cold evaporation, but it's a cloth. Okay, so it's a cloth. Cloth means this water molecules are stick into the surface of the clothes. So that here the bulk water is not here. This is the interface. So what happened here? You have heard about interfacial evaporation. Okay, so that means here, yes, yes, these are pores of the cloth. Okay, if this is the pores of the cloth, and the water molecules are in the pores of the cloth. So here the, compared to the bulk water, here these molecules are the attractive force among the water molecules is less. And here, if the heat energy or whatever the kinetic energy from the wind, it is provided to the, which is inside the pores of the cloth. So that means it needs lesser energy than the bulk heating. So if it's get, even if you hang your cloth in the night time also, morning it will reduce some weight, you can see. That is from this phenomena, that is interfacial evaporation. So interfacial evaporation means it is not a bulk water, it is in the pores of an another surface, here the cloth. So that means it can evaporate even the lesser degree. You don't need 100 degrees Celsius to evaporate the water. It can evaporate even 50 degrees Celsius also. Depends on the conditions. Okay. Then, Next, some water seepage into the ground. So that I already like, if it's a, you know, it is a thing that if the water we are considering, if it's in the pond, we are considering from the pond this much quantity we will take, or in the well, for example, the good example is well. From the well, if we consider the small quantity of water present in that, even there is chances that water can penetrate into the ground again, and the quantity that we can access is can reduce. Then if in the municipal sector we'll get this water, in cities and all they get pipe water. So even if there is some leakage in the pipe, in the, the pipes which provide the water to different homes, then also the expected quantity of water reduce, because there is a leakage, there is a loss. Okay, then next question, what is the assumptions used for so okay, next part is like, from this onwards we are going for a mathematical thing. So um, I will tell you, like, everybody has calculator. So okay, then I will give you 5 minutes break. Yes, 5 minutes break. If anyone don't have calculator, take the calculator. There will be some mathematical equations and problems. Few problems also we will solve. So I will give you a 5 minutes break, and five to 5 minutes break, and you can refresh and come back. Yeah, if you can do it excellent, it's fine. It's completely fine. It's depends on you. Yeah, it's fine. Yeah, it's okay. So 5 minutes break, then we'll continue. You can refresh and come back. Okay, can we start? Okay. Okay, we'll start. First of all, so I told you like we need to find the population. So that is very important for the drainage system design. Okay. So the population prediction, like how much will be the population. From the population, then we can predict the wastewater water consumption, and from the water consumption, we can predict the what the wastewater generation. For that, there are different mathematical formulations are used. So first one, what we are going to discuss is arithmetic increment method. So you people know this one. Okay. So in arithmetic increment increase method, what we are considering assumption is, what is the assumption here? Yes, that mean yeah, that is right. Population increases at a constant rate. That is d. The if the amount of people is p, the amount of difference in p dt is equal to a constant. So that is we are considering the here assumption is population increases at the constant rate. That is k. We are considering the k is a constant. From this we are calculating the predicting the amount of people, number of people in the coming years. So here, for example, we'll solve this problem and get to know what exactly. So you can solve here what I have noted different years 1930 to 1970 with a time gap of 10 years. So then amount of population for this years are given. So this is our basic data that we are using. So we will analyze this data, we will find the k value, and then we assume that this k is constant for the future, and then we are predicting the amount of people in the future. Okay, so then how can we calculate? So you people, you can, if you have this if people have excel, you can use excel, or otherwise if you have a calculator like that, you can calculate. So this is the year and this is the population. Okay, so first what we you have to do is you have to calculate the difference. So here we the increment for the different years we are calculating. So I am writing here increment value. You can calculate this and write in the each column for the difference between this two, this two, this two, like that, this two. So write it here. You can use calculator or anything, then you can write the value here. Done. Okay, here what is the value? Okay, 6,000, 8,000, and 5,000. So then we have how many values? 1, 2, 3, 4. Then we have to calculate the arithmetic mean of this value. So calculate the arithmetic mean here. What is the k? How to calculate? You have to add this and divide it by 1, 2, 3, 4. 5,500. Right. So what you are assuming here, this value, this is the k value, and this is constant. So now the formula is, for example, number of people and the year. Which year? Here, what are the number of people at a particular nth year? That is equal to p naught. Here in this example, what we are considering, p naught is the initial value. So initial value here is what, how many people are there at 1930. So that is the initial. Then you have to add with the value of uh, n into this k. This n is the what decade. So we, the different, we have some, for example, we need okay, for example here, if you need 2020. So for example, we have to calculate for the 2020. So we have to find the difference in these years, 1930 to 2020. How many years? How many years are there? How many years? Yes. Like yeah, yeah, like you have to, how many years you add here with 1930, then you will get 2020. 90 years. Okay, 1930, you're saying 90 years. Yes, 2020. So if it's 90 years, then what you have to do, you take 90 years, then decade means how many years? 10. Then 10 years you will divide, then you will get 9. So 9, you take the nth value. Got it? Yes. Yeah, if you consider the, yes, if you consider the initial value from that particular year, then you are predicting for the some year which is forward to the 1930. You have to calculate how many years are forward. 2030. Then divided by 10, then it will be 10. I didn't get the point. That depends on like what we want. Yeah, that can vary. Okay, got it. No, no, you have to consider 2025. Then you, when you, if your initial value. Yes, 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 got it. Okay, then you have to put the value here. That means P naught, which initial number of people, that is 2000, then plus n, which is 9, into k value, which we calculate the arithmetic mean, that is 5,500. Then you calculate the value. Got it? Hello, you can hear me? Hello. Yes, I think there was some small network issue there. You can hear me? Yes. Yeah. 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 There was small correction. I'm sorry. Here this initial value that we have to take is in question that this particular data we have till 1970. So if you calculate this k value, then you keep it, and then what you have to do is you have to consider the last year that which is given. So that is the initial value, which is 47,000, and then you have to just see this value and see the these two values are same of different. This one, if we consider from both are same. Okay. Yes, yes. Okay, then it is both are right. Okay, because in the I think in the yeah, in the lecture I think it is given like last value, right? So both are same. So last value. Yes, it will same. Okay, right, great. Okay, okay. So any other people had that confusion and done what I'm saying? Okay, for example, if you consider the last value 1970, and the number of people at that year is 47,000. So what is the value of n you consider if you consider 1970? 5, right, correct. Then what you do, you have to multiply with the k value. K value is constant, so you have to do k value. So calculate this, and also you calculate this also. If you take this year 1960, then that is around 42,000, right? Then from 1960, what is the value of, if we have to calculate 2020 population, what is the decades there? 1960, 1960 to 2026. Then you have, what you have to do is 5,600. Got it? Clear? Okay, any doubt? Anyone has any doubt? Okay, now I will give you one question. So for, you have this value which I have mentioned in the board, and then I am telling you to calculate the number of people at 2014, 2070, 2150. So use the values which is mentioned in the table, and everything is calculated. K value is already given. So you have to calculate the number of people on the basis of arithmetic increment method. How many people will be there at this years? P 2014, P 2070, and P 2150. So I'm not calculating this. So if two people gets the two means same answer, then we'll consider it, or I will also do it now. Okay, you can calculate. Okay, so people are writing. So you can tell, like, yeah. 71 uh 200 and 2070. Hmm, okay, just 1 lakh. Okay, 1 lakh 2000, right? Then for P1 2150. Okay, so other people. Have you done? Yeah, yeah. Sorry, sorry. Yeah, this one, right? Okay. So here 10, why we are dividing is we are converting the number of years into decades. So whatever value you are getting, the number of years you calculate like 20, 30, 40 years, then you divide it by 10 and you convert it into number of decades. Yeah. 1,46,000. Okay. Okay. So other people also can do the calculation and let me know. Like, I think after this problem now you all will get to know what it is if you solve it. Okay. Correct. Then second. Okay. Yeah. Yeah. 2000. Okay, okay. Sorry. Okay. Correct, right? So other people have calculated other than this two girls. Other people, everyone calculated. Sorry. Once more. Okay. So we will do census in years, right? So by that we may have the year and the population. And what we do is we will calculate the uh, increment in the amount of population by this data. So this data, have you got it? So year and the population number. And then what we have to do is we have to find the difference in number of people in each time gap, time span. And then we have the value of people, that is delta p we have. So then we have to calculate the constant, that means k, that is the rate of change of people per time span. So k we have to calculate from this value, that means delta p value we have. So from the delta p values p1, p2, p3. Then we have to divide it by number of times that we have considered, time spans that we have considered. Okay, so number of time span here is the one, two, three, four, four. Four time gaps that we have considered. When we calculate the gap between each years, so then what we do, we will calculate the average. So we will add this increment value, then divided by this time gaps. Then we get the k value. So this k value we consider the constant. Got it? No. Got it. Okay. Then that is the arithmetic one. So then what we have to say is, what is the, yes. So then we'll say what are the advantages, or what are the things that in the applicability of this arithmetical geometric, this arithmetical method. Have anyone know? Arithmetic increase method, that is the name of that method that we have done. So what is the, in what type of city, so we have to know the type of place that we can apply this. So it is better applicable to large and established cities. It is better applicable to large and established city, and it also will give lower population estimate than actual value if we use small or average or comparatively new cities. So new cities means we don't know the, number of people. For new cities means the things that present in the cities, that the job vacancies there, or the new industries it comes. So the, different, the hotspot, if the city is new, if the well established city means, okay, well established city means what? So well established city means the city which is fully grown, fully developed, yes. And then, yes, so that means there everything is set. The hospital, other industries, and everything is settled, and that means that it has, it reached as a saturation level. It is, everything is there, and we know that what are the, different stay flat system. Mostly it will be flat system, and then schools will be there, then industries will be there. So everything is fully fledged. We know every hospitals, we know all these things, and the number of population for this type of cities we can predict from the this method, which is the arithmetic mean method. That is, we predict that the rate of change of people during the years are constant. So what is the small cities means? Can anyone give some small like, what is the cities now? It is becoming a city. Yes, that means it is now, it is in the word, it is developing, it is not fully fledged, it is on the path. Okay, so that means for that type of cities it is not suitable. So if you apply to that type of cities, then it will give the lower population estimate value than the actual. Yes. So that means if we apply to the small cities for the arithmetic mean method, then it will give the number of people, the number of people it will give, number of people it will predict, that will be lesser than, it will be less than the actual value. Yes. Yes. Okay, got it. Okay, so we'll go to another next method. right? This is clear, right? Arithmetic mean method is clear, I hope, right? Huh? Okay, so the here the question also will come back. What is the assumptions used for arithmetic increase method? So options are: growth rate is progressively increasing or decreasing, percentage growth is constant, population increases at constant rate. So from the or D option, none of the above. So what is the assumption used for a arithmetic increase method? Which one is the assumption? Option C, right answer. Population increases at constant rate. Okay. So, what type of cities that you apply this method? Yes, right. Correct value. Large cities. If you apply this particular method to small cities, or there is initiation of some hot, small cities, and then if you apply this particular method to that type of cities, then it will predict the lower number of peoples in future compared to the actual value. It will underestimate the calculation. Okay, this method is clear, I guess. Then next method we go. So the next method is geometric increase method. No, before the geometric increase method, yes. Yeah. Geometric increase method. Anyone know what is this? Growth rate is constant. Percentage of growth rate is constant. Here dp by dt is equal to k and pt. That is the percentage. So here we have to calculate the percentage of each year, the time gap, then that percentage remains constant in that this case. In the previous one, k was constant, but here the percentage of the increment is constant for this method. So no worries, like we will do the calculation, then you get to know what is this. The same values we can use here. Yes, if you do the calculation, then it will be easy to know the method. So you can, if you have excel, you can type, or if you have the notebook, you can write geometric increment method. So the same values: 1930, 2000, okay, 2500, 1940, 28,000, 1953, 1960. Okay, so these are the years, and this is the population, which is same like the previous one. Then what you have to, you already know the increment, in this years that we have noted: 3,000, 6,000, 8,000, and 5,000. Okay, then we have to calculate the growth rate. What here is the main factor is growth rate. Okay, so you guys have noted down this. You can write this table. So you can prepare a note for this, so it will be helpful. So you can note it down for the next question. You can write this geometric increment, and this equation you can write, and this table you can draw here. Year, population, increase in population, then growth rate. Then you have to write the growth rate. How you calculate the growth rate? This is the increment in the population rate. You have to, so this is like year, the population in the, so you can write like this is P1, P2, P3, P4, P5. So growth rate you have to calculate from, this is, you have to write delta P, this is here, delta P1, 2, 3, 4. Okay, then you have to calculate this delta P1 divided by P1, delta P2 by P2, delta P3 by P3, delta P4 by P4. So you calculate this and write the values here. That is the growth rate. Here that we calculate the increment in the population within the time gap. Then that population number divided by initial one. If you consider 1930 and 1940, the difference is delta P1, and the initial one was P1. Like that, if you consider 1950 and 1960, the difference is what, P4 minus P3. Then we dividing by the initial one in that time gap, that is P3. Then we are noting down, it is the growth rate. Yes. Which one? Here 60. So here that means you have to calculate 3000 divided by 25,000. That means what is the value here? 512. 0.12. Right. 0.1. Okay, right. Then next one, 214. And then 0.23. Okay. Then, okay, right. Correct answer. That is the growth rate. Then if you want, we here, if you convert into percentage, then how do you do? You have to multiply with 100, right? Then it will become 12 percentage, 21.4 percentage, 23.5 percentage, 11.9 percentage. Got it? Yes, in the time gap. So in the previous one, we take the arithmetic mean of the increment, and here we are going to take the geometric mean of this particular increment, this growth rate. We have calculated this growth rate. Then what you have to do, you have to take the arithmetic mean. Sorry, geometric mean. Here the geometric mean. what you have to do is equal to, you have all these values, you have to add this 12 plus 21.4 plus 23.5 plus 11.9. Then you have to take the geometric mean. Here geometric mean 1 2 3 4 values are there, 1 2 3 4. You have to calculate this value, and that is your geometric mean. That is, this particular value we are considering as a constant. Yes. Yes, yes, to the power 1 by 4. So otherwise, sorry, sorry, it is multiplied. Multiply. Yes, yes, sorry, it's multiply. Sorry. Yeah, yeah. Yes, 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 yes. Yes, yes, yes. Right, right. You have to multiply. Sorry. You have to multiply and find this value, geometric mean. Or otherwise, that is otherwise it's, you can, this is the thing. 12 into 21.4, 21.4 into 23.5 into 11.9. Yes. Calculate this value and tell me. 16.37. Okay, right answer. So here we are considering, this is like the constant. This percentage is the constant value. Anybody have doubt till here? See here in the arithmetic mean, what you have done, you have calculated the difference in the like people in the over the years. Then you have added these values and divided by the time span that we consider. We have, this is like 4, 1 2 3 4. That is the arithmetic mean. Then we are going to geometric mean increment. That means here what we are doing is, we are, you know the values of the people, like increment values of people all these over the years. Then you have to calculate the growth rate, that is this one, delta p by 1, difference in the final and initial people divided by the initial people. Then you got the growth rate, then you convert into percentage, and these percentage we are going to calculate, going to consider for the geometric mean. We'll multiply each values and taking the geometric mean. So here if this is 4 values we got, then that's why we have taken 1 by 4. So for example here, if I'm just adding, for example, you please calculate 1980. I'm adding one more value here, p6. Here for example, I'm considering this is like 55,000. Then add this other, this all columns, 1 2 3. Find out this values. What is the increment in the population growth rate? Calculate this and tell me. You guys found? Okay, here, starting from here, population increase. 8,000. And what is the growth rate? 0.17, that is here 17 percentage. And then you have, if for this case, if you want to calculate the geometric mean, then what will be 12 into 21.4 into 23.5 into 11.9 into 17, then the whole raised to 1 by m. What is this m value here? Yes, right. 1 by 5. 1 by 5. What is the value for this geometric mean? 16.49. So, got it? Like all doubts are cleared. Anybody have any doubt in this till this? Hmm? If anyone has doubt, please raise. Okay. Now we have to calculate the population. Now don't consider this last column for now. Don't consider this one 1980. Consider you have only data from 1930 to 1970. What you have to do is you have to calculate the population at 2020. How we calculate? So for that, the formula is the population at nth year is equal to population initially, like what we are considering here, you can consider 1970 population, then into 1 plus this r divided by 100. This r value is the value which we calculated here, geometric mean value. So this is the r. Okay, r, then the whole raised to n. So this n value is the number of decades from which year you are considering. Okay, if you are considering from this 1970, then you have to consider 1970 to 2020. If you are considering, then what you have to do is 1970, the people value, how many people are there, you have to note it down. And then you have to consider the r value which we calculated, and this n value is the what, the number of years. I think this is 50 years, right? 50 years, right? 50 years, right? Anybody has doubt? And then how do you convert into decade? 50 by 10, then 5. So this n value is 5. So now please calculate putting the all values here. So this is the equation, and R value consider only till 1970. So here 1930 to 1970 values are you considered, and you have calculate the R value. You have calculated the R value here. This is the R value 16.37, and then you have calculated the N value from 1970 to 2020, that is 50 years. You convert it into decades by dividing it with 10, then it is around 5 years. Then if it's 5 years, then you put the values in this equation, then calculate the number of people. 1 lakh 300, that is right, correct answer. 1 lakh 300. So now you, so R value is here, the geometric mean that we have calculated. This one. So now, okay, don't, no worry. Next, again you do. If you consider 1930 to 1980, so do the same. Okay, consider what is the number of people 2020. If you consider this value 1980, you are considering the values from 1930 to 1980. You are considering the values from 1930 to 1980, then calculate the value of number of people expected in 2020. Okay, yeah, yeah. 1 lakh, 1079. 2 lakh is 79, like this, right? Okay. Yes. Got clear? Any doubt? Any doubt? Then, okay, you consider only these values. You don't need to consider 1980 value. You don't need to consider the 1980 value. Only consider this value. R is equal to 16.37 percentage. And you calculate the number of 232. What is the number of people at 2032? Yes. Consider the peoples from 1930 to 1970. Only consider this only these one, 2, 3, 4, 5 columns, 5 rows. Then consider R value. Anyway, I noted down the R value also here, 16.37. And then consider here 1970 value 47,000 is given. What is the number of people as 2032? And here the formula is given here. You can see the screen, I hope. P naught into 1 plus R by 100, the whole raised to n. N is the decades, R is the geometric mean percentage. 1 lakh, 1 lakh 20,000. 20,313. Okay. Okay, I think now your this type is also clear, right? Got it thoroughly? It is clear, right? Everyone, hopefully everyone got this from two problems. Then what for this method? Got it now? Everyone? Anybody has any doubt in this? Okay. This method, which is geometrical increment method, increase method, this is used for small and developing towns, young and developing towns. Okay, got it? So here, next, okay, here. So the next question, geometric increase method is more applicable to which cities? New cities with unlimited scope of expansion, large and established cities, cities of moderate size and age, and D, very large cities with sufficient demographic data. What is the answer? Geometric increment method is more applicable to which cities? Anyone? Option who have notified option. Oh no, option C is wrong. See here, geometric increase method. Increase method is applicable to which cities? It is the option is A, new cities, that I have explained to you, young and developing cities which have unlimited scope of expansion. That is like, for example, in an area, so there is a city, if there is a small city, but if there is a new port is coming there, if there is a new port coming nearby, or if a new, there is a city, already there is a city, but there is new, scope is there. There is, okay, aims have established, aims have come, that medical university. So then another, big industries also have established here. So here in this city, it is, that because of this this institute and the industry, there will be a lot of people come in this area, and those people will start accommodating here. They buy flats or buy new or rented home, or they build home, and they started living in the cities. And from this this is college, from this college there will be scope of small shopping city shopping stores will come. And then there will be, this is for dress or some other things. And also there is food, for the food also there is a scope here. Food means there will be juice shop, there will be a big restaurants, because there is a lot of people coming for aims and industry. So then they need, pleasure time, they need to drink, they want different enjoyment, they need also, if they are interested in sports. Yeah, most of people, in this big cities, they will find leisure time, they want to do some sport activity. So they will be, a badminton court, there will be the scope of badminton court is there. So that badminton court means people evening they can go and they can play. And then there will be swimming. So there, because of this, new industry and institute, there is a scope of different business ideas there. So then there are people will build different things. So like that, if in even in aims or exam, otherwise if IIT is coming here, IIT also, so then there will be a lot of staffs, and that staff may have children, and then those children need, schools, so small schools will come. So like that a city is, developing, and this particular area has a scope that it will have an advanced state. This is young but it is developing, and we know that there will be an growth, a huge growth in population in future years. And this type of young cities and developing cities, and we are sure that there will be a huge number of population is going to come here. So these type of cities we are applying geometric increment method. Okay, got it. Then, okay, so this one, so this is one of the assignment question it is given. So you just read this. This is they have given the year and the population. So Using arithmetic increase method, what will be the estimated population in 2020? So you write this question and calculate the increment values, and then take the mean values, and from the mean values just put it in the equation. Arithmetic mean increase value, which is the method that we have discussed first. I can give you the formula. P 2020 is equal to P naught plus the constant value into time. And here also you can, I will give you this formula also, initial number of people, and here you have to calculate the number of years in decades, and then this is the decades, and then this is the mean value. You have taken some value mean, then calculate the number of people and 2020. T, it's a decades. If you take 2010 and then you 2020, what, how many years, and take it convert into decades. K means it is the mean value that you have to calculate from the difference in people. Got the answer? Okay, what is the option D, right? How do you calculate? So anybody calculate other than you? Okay, P naught. What is the P naught value here? Yes, right. 52,000. You can take any value, but you consider 52,000. What is the K value? Okay, K value. What is the K value here? 2010 to 2020, right? 10. It is 1. And then multiply with mean. What is the mean you got? 13,500. Okay. Then it is, right? So if you take even 1930 also, how it comes? It is like, now you have considered 2010 here. If you consider 1990, then it is like 2500, 25,000 plus difference between 1990 to 2020. How much? 30, right? 30, right? 30. So you convert into decades, it 3. So it is 3 into 13500, right? So in both method you get the same answer. If you got it, I hope now arithmetic increase method is clear to everyone. Okay, clear. Okay, thank you. Then, okay, then, okay, for I think today we'll stop our class now and we will meet on next. Huh. Yes, yes, sure. Municipal and domestic wastewater. Okay. So municipal means that we are considering as a municipality. So, okay. So municipality means what we are considering like, I think today I will tell you if some correction is there, then I will tell you in next class. As far as I'm thinking that municipal, domestic, like we interchangeably use. Domestic means from, from home, what are the things that we are, eliminating consumed water which become convert into the wastewater, that is the domestic wastewater. Municipality means we consider as in a city area, that is in the municipality, right? In otherwise village we will tell. Municipality we will tell for the corporation area, that where we use the municipality word. So that means municipal waste means also like the waste which is generated from the domestic, that means from the home. Huh. Okay. mm, that I have to recheck. I will tell you next week. That if some agriculture is also coming, I will tell you next week. But in if you consider, yeah, yeah, I have doubt, so I will tell you next week. Another thing, what? Yeah. Agriculture also in combined one, agriculture will surely come, because in other ways, if you if you just water the plants also, the amount of water which you are giving the plant is less, and there won't be water, enough water, that much flow won't be there. If there is a rain, or there is a, then you may have a lot of water which can flow easily. But there are field like, paddy and wheat field, where amount of water is needed. If they have, specifically the water is there in the field itself in a huge quantity, when we compare to other crops. So I think, for that cases also, if you have rainwater, then, or when there will be a flow of water through it, then only they get enough, pressure or turbidity to take all the pesticides and chemicals which is applied to the field, that can, transport from agricultural field to the normal, that sewage or drainage, because overflow can happen. So otherwise this agriculture, the water is only stay in the field. When there is a runoff only, stormwater runoff only, then only this water can flow through it and transport to drainage. Yeah, yeah, sure, sure. Yes. Yeah, yeah, sure, sure. Yes. 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 Huh. Yes. Okay. Yeah, you're right. Yes. Yes. Okay. Mm-hmm. Okay. 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 Makes sense. Makes sense. Yeah. Then, like that, you people also can. In that, I think in municipal, like what? Yeah. Dhanshree, you want to add something? Agriculture. So you have, yes, municipal. That's what industry. I think in municipal wastewater, only the domestic, and what he said is, I'm not thinking that industry also comes for the domestic municipal. But I have to recheck. So Dhansri, you have anything to add? You have. Okay. So agriculture runoff. So agriculture runoff is simple. See, agriculture waste means that you are adding some pesticides, that chemical pesticides you are adding. So if you add that pesticides, if you add in the leaves or in the plant, it will accumulate in the plant body and also in the soil. So once this water, if you water the plant, if you water the plant, the water will pass through the plant body and this chemicals will reach to the soil. And if the rain is coming, so if enough water is pouring into the field, then all this chemical which is died, which is reached and aggregated on the soil, will will flow through the this water that we have applied the chemical pesticides. And also we use that phosphorus and nitrogen supplement for the plant growth, and these all chemicals will dilute in the water and it will flow. That is the agriculture. And also more than that, there will be sediments. So when the water forcefully pour into the soil, there will be a turbidity that produce that sediments, small soil, soil particle will mix and it will create a mud, mud, very liquid mud. So that is also a plant runoff. So pesticides will be there, phosphorus and nitrogen supplements, and then other than that there will be small pebbles, or there are diluted soils. uh, it's like a mud. So that is the agricultural runoff. Is that clear? So you can, we can see also in agriculture with some uh, photos. See here. So there will be the water which is diluted on the soil, and then it is coming to the some source, that water is collecting and creating a bigger water body here. Okay. So then also I will show you the turbidity. See the turbidity. This was I am mentioning. See, the sediments are mixed, and then it is mixing, and see the water. It's becoming muddy. Like see the color, brown colored, and the water is mixed, and this become a turbid. So this is the mainly this has pesticides and this other nutrients, and also with this mud it is diluted, and the small pebbles and this all are flowing through the water. Got it? See this? Yes, got it now. So municipal wastewater I will. Okay. For what one you are telling? Municipal wastewater, okay. So that means agriculture waste also is there. That's what you're telling. Okay. Okay, I will prepare a specific PPT for that, and next class I will show you municipal and what are the things come under that, and what is the difference in the uh, agricultural waste thing. Okay. So yes, 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 yes. Oil spill. Oil spill is very simple. That uh, industry waste. Yes, it's an industry waste. So you also have idea that we actually. Yes. Yeah, who yeah, yes. Agriculture runoff is a, yes. Why, who see what is the municipal waste you were telling, who were telling that? I think Sangamitra, she's left. Okay. So the municipal waste difference between municipal and agriculture, this thing I will prepare a PPT and tell you. Okay, municipal waste industry cannot come, I guess. As far as I know that industry waste cannot come, because industry waste is completely different from the household. Okay, so these things I will prepare some PPT and with some animated thing, and I will show you so that it will be more easy to understand. Now I think it's more complicated. Yeah. Mhm. Okay. Yeah. Yeah, I told you the difference between municipal industry and also one thing, municipal industry and agricultural. Okay, don't intermix these three terms. So I will, yeah. So I will tell, yeah, I will take. Okay. Yes, that I will tell you. Like with this four terms: municipal, agriculture, and domestic and agriculture runoff. These things I will, prepare some different PPT, and with given some example. I will give some example. And what is oil spillage? You know what is oil spillage? Chitra, you can comment on that. Yes, industry, oil. So, yeah, yes, and also we know that crude oil industry. What we are doing in, even we are also taking crude oil. So what? How they take the crude oil? They will build a pipe, and they take from the underground. So from that we will take that full source. Then we have to separate for our use. So what we do, you will separate it by using different treatment mechanism, and we take the needed part, and the remaining thing we you will dispose either in sea or some water body or in soil. So at that time this particular part have the oil part, which they cannot be taken out. So this is the oil spillage. That means in the brine water or wastewater there is the presence of the oil. And what there are different technology now it is raising to treat this oil. What is the problem with oil? Anybody know? Like we can treat other, wastewaters and all. by using different methods. But oil means it has different, we need for membrane technology also for treating the oil. The surface should be oleophobic. Anyone know that what is oleophobic? It's not only absorb, it is actually, the hydrophobicity and hydrophilicity of the surface. So even if you take a hydrophobic surface, and if you put the water, then you see the hydrophobicity. But when you apply the oil, it won't be same for the hydrophobic surface. So for that you need oleophobic surface. Oleophobic surface is like it have the hydrophobicity, it can provide even for the oil. So then only you can work with the oil spillage. Okay, so I think next class I will give you very short. That is, yes, uh, it's a point. For the industry means it is a point, right? We know the source. But if it's in a but as in the previous class also I told you, like the oil which is in the mined area and all, mined area, and then there will be disposal in the mined area, then water, from the rainwater it is coming, and it will carry that different chemicals from that area, and it will transport that, to different region. Then it become a non point, because we don't know the source that time. So in oil spillage, like, yeah, from the land, you are right. What I'm saying is, yes, yes, yes. That's what in industries. Where is yeah, even in the industries, if you are spilling in the water, or they are producing some wastewater, and that wastewater has the oil spillage, then you know the source. This from this particular industry, and it is here. Then from their wastewater, the oil is there. Then that is, we know the source. But as you said, if it's in the land, then they are just disposing in the land or water in a very, they don't have any treatment system, they are just disposing it. Then from the water, from the run of water or storm water, it will mix with that, then it will run. Then we don't know from where it is coming. It is coming from some other area, or we don't know. We just saw the oil spillage in the storm water, and we don't know from which area it comes. Then that is like non-point. Got it? So the specific industry wastewater, and you know that wastewater has the oil, then that is point. But if the question is from the oil spillage, um, in the previous also I have, yes. Hmm. Yeah. Uh, huh. Yes. Yes, that what I am telling it, in some industries there are technologies that is called zero liquid technologies, that in the previous class. So in those industries which adopt the zero liquid technology, they will treat this wastewater, oil wastewater. So that particular point, you if you treat it, then you are actually separating the oil. But unfortunately in India, there are very, there is no, such the oil treatment. It is very difficult, and maybe one or two studies are, the exact mechanism to separate the oil is very different, and very difficult. Very few technologies are there. And what I'm saying is, if you have some runoff water from the large area where this there is no treatment, they are just disposing somewhere on the soil or water body, then you collect from the water runoff, then you see the oil content, then that is a non-point, because we don't know the source. I hope the point is clear. Okay. Yeah. So, huh, and that was wastewater. Yes. And that wastewater should not, that wastewater should be treated. Otherwise, if they also just disposing it, we don't know the end source. Sorry, Maunika, you said something. Okay, so I think this type of discussion and the going class is good. I think you can refer and come and we'll discuss like this. This will be good. Everyone will come to know new points. Okay, so next class I will that run what you guys were discussing. I will give with the proper presentation and present you. So I hope we'll end the class. Right? Any more questions? Yeah. Sorry, you can you read one more tell? Can you tell once more? Huh? Yeah, in India there are if you go to any water source, river I'm saying, in river you see most of the rivers are polluted. Most of the rivers are polluted. But if you go to any other country, see have you heard of that amoebic infection? Like nowadays, the brain eating amoeba is increasing. Like many people got infected. Why? That is because our sorry. Swimming pool. Yeah, if even in the swimming pool or in the river, if in the previous times, if people take bath even in the small pond, also they didn't have much problem. But now even in the pond or in the water body, there's lot of contamination is there. So this will contamination means there are a lot of nutrients there. So it will help the amoebas to grow and it will infect the people. So in India, most of the water bodies are now polluted. That's a specific thing. But there are some industries. If you check in the net, zero liquid technologies in India. So you find some industries who are doing zero liquid in discharge. Okay. Okay. On so you are asking me the percentage. Actually, I don't know the correct percentage, but I hope it will be more than, I think treatment is only 20 to 30%, I guess, as far as I know. 30, yes. Okay, okay. This percentage can vary with years and all. Some new regulations can come, and like that, it will vary. Okay. Yeah, if I get some data, then I will talk to you on regarding that. Okay, how much percentage of water is treating in India? Sewage treatment is there in India. Yeah, surely I will discuss in next class. Yes. Okay. Any more? Okay. So I hope the classes are useful, and we'll go like a discussion mode only. I think it will be more beneficial, and everyone will be more active. Okay. Okay. Thank you. We'll end the class for today. Thank you very much. Okay.